So I'm going to talk to you today about utility scale solar for landfills. And I don't work for a solar company. I know a little bit about waste and I know a little bit about solar, so I'm going to try and condense what I've learnt so that you guys can take it away and have a think about whether it's something that might be applicable to your landfill. And my audience that I'm going to talk to today is local government. The same kind of approach applies to commercial landfill operators, but I think local government is in a sweet spot to capitalise on utility scale solar. So what does it actually look like? It's not rooftop solar. It's large scale. So this is an artist's impression of the Summerhill landfill in Newcastle, and it's big. So it's generally anything that's over 1 megawatt in capacity, and it has the potential for you to generate renewable electricity and to actually export it to the grid. And it makes use of the land value of a landfill that doesn't really have a lot of use typically, apart from maybe sports fields or high vantage points if you build landfills in Queensland. So what are we actually talking about? Essentially, the key elements of a utility scale solar project are you have photovoltaic cells on top of a waste mass, which is a closed landfill. And the uniqueness of that means that you're placing essentially a fixed piece of infrastructure on top of a settling waste mass, which also produces landfill gas. So there has to be a way to accommodate solar with landfill gas. But simplistically, you're looking at solar panels essentially that convert particles of light from the sun into electrons. Those electrons then get transferred into wires. Then you have an inverter that converts DC to AC so that you can put it into the grid, and then you sell the electricity into the wholesale market. They're the kind of key elements of it all. So why would local government actually want to think about utility scale solar on a landfill? Probably the number one reason is that there's a hell of a lot of councils that have renewable policy objectives. So there's just 3 of them. And they're kind of bold in their targets. And many local governments have actually gotten to a point where they've kind of maxed out, how many panels they can put on libraries and buildings, and they haven't met these targets. So if they want to actually achieve those targets, then they either need to purchase green power from a retailer, which often comes at a premium price because the retailer is sourcing that from a commercial solar operator and adding a margin to it. So does it actually need to be kind of trying to achieve those policy objectives at all cost? Trying to drive 2 bits of technology is pretty hard for a man. So the other key drivers are financial. So councils are big users of electricity. There's pools, water treatment plants, sewage treatment plants, admin buildings, all of those things consume electricity. And they're actually committed to that spend. So as long as they're, I suppose, delivering those services to the community, they're going to have to spend money on electricity. So solar is just a way of basically replacing that, allocating, I suppose, the funds that they would typically use to pay a bill to a retailer and using that money in a different way to run their own utility scale project. And on the flip side of that, in terms of landfills, landfills generally, or councils, have a 20 or 30 year responsibility to manage a landfill once it's closed, which kind of matches out with the lifetime of a utility scale solar project. So just to get a bit funky on the numbers, if you're a landfill operator, this just shows basically that for a long time you've been operating your landfill and you're generating revenue, and then you get to a point where you've actually got to close it, and so you incur, if you haven't been progressively capping it, you incur a big capital cost to construct a final cap and meet your licence obligations. And then you've got 20 years of maintenance. And overlapping that, if you're big enough to have a power generation plant from your landfill gas, when you stop accepting your waste, you get to a point where your actual gas yield starts to reduce. So the revenue generating potential from your landfill gas actually diminishes over time. So, because I like numbers, we just, this is kind of hypothetically, but all of those costs to do your capping and your maintenance cost about $11.4 million in kind of NPC terms. So all of a sudden you decide that it's a really good idea to put a 5 megawatt solar farm on top of your landfill, and you get to a point where you've capped your landfill and you install the solar farm, and you've actually got something that generates revenue through the sale of electricity, and it matches off against your actual post-closure costs that you incur at a landfill. So what happens is that, if I can get this to work, that $11.4 million that we talked about previously all of a sudden becomes $2.9 million. It's a pretty kind of compelling argument if you've got the right site, you've got the right scale utility. I'm sure most councils would be happy to have that scenario rather than paying post-closure costs to the tune of 11.4. So what are the challenges? Well, the main challenges are the fact that you've actually got to install a piece of infrastructure on top of the final cap. And obviously, landfill operators invest millions of dollars in the design and construction of the final cap to meet the licence obligations, and they want to minimise infiltration and they want to minimise leachate generation. So a solar farm needs to be built in a way that actually minimises the impact on that final cap, particularly during construction phase. And there also needs to be some attention to how the solar farm actually interacts with landfill gas, because I'm sure the landfill gas operators or contractors of the world do not want something that impacts on their piece of infrastructure, and it also needs to accommodate any future or development of landfill gas infrastructure. And any impact on those two things is likely to incur the wrath of the regulator as well. And apart from that, there's community concerns around, you've got a whopping big glare hazard and those kinds of issues. I'm going to look at this solar farm from my property and I don't really like the looks of it. So there's the typical community concerns. So just to kind of go through the key elements of a landfill of a solar project. Basically, you've got PV panels. So this one over here is PV panels that are on top of a geomembrane. That kind of technology came out in 2009 in the US, and it was a bit early to the market and not really commercially successful. So you typically wouldn't see that. If you look at all the solar projects on landfills around the world, you don't see a lot of geomembrane with solar on the top of it. You see more of this sort of thing, which is essentially a fixed panel. And so a fixed panel or a fixed tilt rack is just a steel frame on a fixed angle, essentially to maximise the light absorption from the sunlight. There's no moving parts, so it's got really low operational maintenance costs. The disadvantage is that it actually produces less energy because it's not tracking the sun. The alternative, and I don't have a picture of it here, is a thing called a solar array, which essentially tracks the sun as it moves through the day. The advantage of that is that it basically has like a 25% higher energy output than a fixed panel. The disadvantage is that it has a higher O&M cost, and the major disadvantage on a landfill is that you get settlement, so it's not really that suitable for a landfill. So you're kind of stuck with a fixed tilt panel. The next thing is foundations. So there's really two types of foundations. There's the ground-mounted foundation and there's a screw pile. So ground-mounted obviously sits on top of a final cap, whereas a screw pile would actually have to penetrate into a final cap. Both of those have been used overseas. We've had some experience recently with a council that's looking at doing this in Australia, and from the tender submissions that we got, I think 10 of them were looking more favourably at screw pile over ground mounted. And there's some reasons for that around cost, but from what I've seen overseas, the preference is actually to have a ground mounted foundation, because it just gets placed on the surface of the landfill. It accommodates the settlement, and all of the conduit and electrical cable can be run over the surface of the landfill. So it protects cap integrity, which is what we talked about before as one of the key challenges. The next component is grid connection, and this is the biggest, I suppose, project killer or the biggest value creator of utility scale solar. So essentially, if you're going to sell electricity to the grid, you need to connect to the grid. So there's a whole, I'm not an electrical engineer, so I'm still trying to get my head around the world of network service providers, but essentially there's different transmission networks operating at different voltages. If you're connecting to the 11 kV transmission network cost you about $500,000. If you go to a 33 kV, it's $3 million. If you go to a 66 kV, it's $5 million. So it's pretty easy to see that if you're building a 5 megawatt utility scale solar project and it's creating you $8 million worth of value and it costs you $5 million to connect to the grid, then all of a sudden the project financial argument doesn't really stack up as neatly as what it would have if you're connecting to an 11 kV network. So the sweet spot is an 11 kV network that runs past your landfill and enables you to put say a 5 megawatt solar farm on your landfill. The good thing is that there is actually a regulated pathway to consult with a network service provider like Ausgrid or Ergon or Energex in Queensland. The bad thing is that if you can find the right person in one of those utilities to give you the right piece of advice in a really quick manner, you'll be waiting a long time. It makes local government look like massively efficient. Couldn't help that. So, what makes an attractive landfill? There's a few things. It's got a good buffer zone. And I should have said probably that you can not only, if you've got a big enough landfill and you've got a big enough buffer zone, you don't have to restrict yourself to just building a solar farm on top of your landfill. If your buffer zone's big enough, then I'd be having a look at that as well, because it's going to be a lot easier. If it is capped, if you are building on a final cap, ideally the cap's 1 metre in depth, and you have settlement of your waste mass, big slopes with not much grade, and preferably unshadowed, so no big tall eucalypt trees growing around, low methane levels or an active extraction system, and like I said before, the network connection. So just to give you a sense of does this actually all kind of stack up, this is just some numbers, because I like numbers, about does this actually make sense. So I'm a local government and I've worked out that my electricity bill is close to $15 million because I want to meet some renewable energy targets that my councillors have set. So I've done the homework on what's it cost me to, why isn't my technology working? What's my electricity bill? And then I come along and go, I'm going to build a 5 megawatt solar farm on top of my landfill. It's going to cost me about $8.5 million. I've got some operational maintenance costs around, regular maintenance. I've got to hire some goats to mow the grass underneath the solar panels. But once I've made that investment, I actually generate electricity, and I can also sell large-scale generation certificates into the market. So my bill automatically comes down from 14.6 to $6.6 million. And you don't have to be a rocket scientist to figure out that there's actually a budget saving. So council consumes the same electricity. They're just offsetting it with electricity that they're producing at a utility scale solar project, and they're saving themselves some money on the way through. The lights aren't going to go out, the pool will still be warm, and the water and sewage treatment plants will still continue to operate. The reason that local government is an ideal investor in this space is that council can be its own customer. It actually consumes electricity in big quantities, and it can use renewable energy to net the renewable electricity off against their electricity bill. Landfill sites have big buffers generally. Council's got responsibility for 20 or 30 years, which matches the useful life of a solar project. Council also has the fortunate position of being able to borrow money really cheaply and to set long fixed terms, which kind of match a solar project as well. And councils don't generally have a return requirement the same as the commercial enterprise. So councils might be happy with a 7.5% return, commercial investor might want 10 or 12%. So councils can take the longer term that enables them to get a payback that is satisfactory generally to their councillors. 2 minutes? I thought you were getting phone calls before. And there's also the value around the social, environmental and educational benefits. Luckily I plan as well. So if you're going to run through this project, you do it in a staged way. You don't want to spend gazillions of dollars on dodgy consultants like myself when you could do some of the work yourself. So the first thing to do is there a strategic reason to do this? Does my council have renewable policy targets? And what am I going to actually use my landfill for when I get to the end of its life? If that stacks up, then do a preliminary feasibility to look at the high-level economics and the technical challenges that you might face on your landfill. And if that makes sense, then you move to a detailed business case to do more detailed financial analysis, particularly around looking at what council spend is on electricity. And that generally becomes the biggest hurdle because the electricity bill is split across 15 different functions in council, and trying to get all that data together is inordinately time consuming. But at each step, you should actually go back and kind of do a health check and retest, are my assumptions still correct? Can I learn anything from actually engaging the market, and what lessons can be learned from other people who have learned some things along the way? And finally, just a quick project checklist. So the first thing to do is to do a network assessment. Have a look and see how close you are to an 11 kV or 33 kV. Engage a network service provider early. Engage your landfill gas contractor early, because if they're doing power generation, you may be able to actually use some of their substation infrastructure or connect into their infrastructure. Just as a kind of a rule of thumb, in terms of land area, you need about 1.5 hectares for 1 megawatt. It gives you about 1.6 megawatt hours per year. This is the last slide. And it costs you about $2 million. Obviously, you need to look at your site constraints, buffer area, final cap, landfill gas, visual amenity, and lastly, do a financial assessment. So I hope that's given you something that you can take away and have a think about. It's not going to be suitable for every local council, but I think the market in the solar space is changing. It's becoming more cost effective to install large-scale solar, and local governments got the right kind of financial and social objectives to take action in that space. Thank you.